Assalamu alaikum. I am Hania Huda and my other group members are Arooj Badr and Bilal Ahmed Ismail, and the research paper we have selected is Digital Forensic Analysis of Instant Messaging Applications on Android Smartphones. What is digital forensic? Digital forensics is the science and practice of identifying, acquiring, analyzing, preserving, and presenting digital evidences from devices and network for crime investigation and court uses. But why the research is targeting Android smartphones? The reason is a significant impact has been made by Android on the smartphone market and in the area of digital forensics. Android has taken 87.5% of the global market share with a total of 1.4 billion users in the world currently. Now coming towards the need to digitally analyze instant messaging application, what is the need to do it? Instant messaging applications are used for sending and receiving text messages. They are now media tools to share and exchange data via the internet in various forms like text, pictures, audio, and videos. In addition to basic instant messaging functions, most popular instant messaging applications have built-in advanced features such as encrypted chat, file transfer, friend circle, and status following. Along with the rapid growth of instant messaging applications, cybercrime has emerged as a serious concern to public security, and the encrypted chat functions could be used by terrorists for communicating with one another. Therefore, digital evidence acquired from instant messaging application is considered critical for criminal investigations and court evidence proceedings. So in this research, important evidence from the metadata of some popular instant messaging applications is identified, then the data is acquired and analyzed. The main purpose of this study is to provide a guide for mobile digital forensics investigation based on instant messaging applications. The problem this research targets is the use of instant messaging applications in cybercrimes like terrorism using digital devices. The encrypted functionality of these applications is useful but also have some disadvantages.
Yeah, onwards, we talk about the tools that are being used in this study. First of all, two smartphones, Nexus and Moto E, were selected, and four of the most popular messaging applications WhatsApp, Hangouts, Line, and Messenger were investigated. Furthermore, for forensic tools, Fastboot, Minimal ADB, SQLite Browser, HexEditor, SHA-256, some etc. were employed. Now moving towards the methodology or the proposed solution, the only communication channel that was established and monitored for the exchange of instant messages was between Nexus and Moto E, the two smartphones that were selected for the experiment. Investigation of application and installation file structure for both phones was conducted to discover locations of forensic evidence. We have seen that in this paper, SHA-256 sum is used for integrity check, where hash is calculated before and after chat activities performed. So for a possible change in the value makes the data potential digital forensic evidence, and data in SQLite DB was further analyzed. This study shows that different type of files are stored at different locations. We can see that the location of APK files is different from database files and cache files of user activities. It was observed that these four applications follow different strategies for storing encrypted and unencrypted data, and forensic procedures were then performed in those locations to extract potential data for evidence.
Thank you, Hania and Aruj, for the insight on the study. Let us now move over to the results and outcomes. We have analyzed the storage path for the APK files, databases, and the media storage as stated here. Moving on to the messaging applications, we have WhatsApp as the first one on the list. We have analyzed that it had two databases, SQLite databases. First one was messagestore.db, and it contained all the conversation information, whereas wa.db contained the information regarding the contacts. Similar to this, we had Facebook Messenger, and in which we analyzed two types of chats. First one was normal chat, which had a similar pattern to WhatsApp. Here we had threads db2, the database in which the conversation details existed, whereas contacts db2 had the information regarding the contacts. It even had information like the coordinates of the sender's device, although the images and audio were in separate directory. We can see private chats were a new addition to the regular messengers. Here we had self-destructing messages, so if we had to take an image for forensics, we'd have to take it earlier to it being self-destructed. Moving on, we have Hangouts on the list. Here, the database file that we had analyzed was Babel -.db. Hyphen actually refers to the user number, so it's going to be different for every user. And it had all the information, the contacts, the chat information, everything under one database. So querying results had to go through joins and different kinds of queries to yield favorable results. The last one on the list is Line. It has two databases just like WhatsApp and Facebook. First one is end-to-end encryption.db, e2ee.db, which stores the public and private key for live chats. Whereas the other one, neighborline.db, it has chats and contacts, everything else, and stored in it in an unencrypted manner. Moving on to the conclusion, uh, just making it concise, we can see Facebook has two messaging modes, normal and private mode. Hangouts, on the other hand, does not have any encryption, so doesn't refer to privacy at all. Line has some privacy, but only for the live chats, whereas the offline data, the database storage, is completely unencrypted. WhatsApp, although, has end-to-end encryption, and it even has database storage encryption, which, although, is not really encrypted when you have a rooted phone, then you get it unencrypted. So if there's no end-to-end encryption, a simple conversation is very likely to be eavesdropped, and this can be done by just a simple traffic analysis attack by Wireshark. For local databases, no databases were encrypted in rooted phones for our case study. User data at stake if root device gets in wrong hands, and this is obvious. And for future work, recovering information from deleted or encrypted databases is of utmost concern, even for the forensic investigators. For dealing with really sensitive matters like terrorists or any other unlawful activities going about in the state.